To start with the Scikit-Learn story, our goal was really to build a machine learning toolkit for everybody. And for this, the first thing we did was that we embraced the Python stack, which back then wasn't as popular as it is today. The reason we chose Python is because it's interactive and easy, but also because it's general purpose. So it can be mixed with other tools that are not pure machine learning, such as web stack, text processing, image processing, you name it. What was crucial for our success was that Python was built from the beginning to be embedded. And this conditioned the choice of a very simple virtual machine. So it doesn't have fancy and powerful things such as transactional memory, and rather it has very simple tools such as reference counting, garbage collection. This means that it is very easy to couple the Python virtual machine with external programs. The other thing that we embraced was NumPy, and we embraced it for the numerical operations that it gives us. But really the way we need to think about NumPy is that it's a continuous memory model. So it's some form of float star, some form of C pointer, and an abstraction on top of this. And this is extremely useful because it allows us to couple to other libraries. And so these two features are crucial because they enable bridging across languages. So typically we can reuse code in C, such as layback, and they also enable Python, which is some form of a high-level compiler from a Python-like syntax to low-level, such as C. And we've been using this hugely in Scikit-Learn. Next, because our goal was to enable people, we focused a lot on usability. And for this, we put a lot of effort on API design. The principle behind our API is the principle of gray box. The idea being that all models are interchangeable, but they're still inspectable. You can still, to a certain point, open them and look at them. We also invest hugely on documentation and example. There's so many problems that are better solved by explaining something rather than coding more complex models. And the way we do it is that good documentation is required to add a feature. We guide our API design by crafting easily understandable examples. And our goal when we write Scikit-Learn documentation as an example is to teach statistical learning and not to teach code. Ideally, people shouldn't worry about syntax. They should worry about the data science problem they're working on. When we integrate code, when we integrate a statistical model, a solver, when we make choices of hyperparameters, each time we make those choices, we choose the option that does not require tinkering from the user. And this is actually a very difficult problem. And we do this via a lot of use case-driven empirical testing. Finally, the secret weapon of Scikit-Learn has been the community. From the start, our decision-making and our development has been distributed across many countries, many continents. This gave us manpower. We have typically 30 to 40 monthly contributors, and they're not the same people every month. So this brings a lot of different people to work on the project, but it also brings a lot of diversity, which is extremely interesting because this diversity helps us have the right focus. People will come, fix, and improve what's important to them. So it is fair to say that open source has won. This is a successful open source model. However, it needs sustainability and it needs continuous investment. And more recently, we've turned to private partners. We've built a foundation where we have partners who are mentors, and they help us pay core contributors who work on the project and support the wider community.